basically, the Hubble Space Telescope, otherwise known as the HST, is a space telescope that was launched into Earth's orbit in 1990, and it is still in service to this day. The Hubble telescope is one of NASA's greatest observations. So next, we're just going to briefly introduce Edwin Hubble to you guys. Basically, Edwin Hubble was an American astronomer. He played a crucial role in establishing the fields of astronomy and observational cosmology. His name is widely recognized for the Hubble Space Telescope, which was named in his honor to his crucial contributions to science. He invented the Hubble law that indicates that the universe is expanding. He also provided evidence to that. And he provided evidence that the recessional velocity of a galaxy increases with its distance from Earth. And he proved that the clouds of dust people used to classify as nebulae are actually galaxies, which we will see later in this lesson. The historical timeline. So basically, back in 1983, NASA named the telescope after Hubble. And in 1990, in April, it was actually launched into orbit. And in 1993, it measured how far a certain galaxy from the Milky Way is, which helped us learn the rate of expansion and, in turn, the age of the universe, since time and space are relative to each other. And in 1994, specifically in May, the HST detects giant black holes in the centers of galaxies. And also in 1994, in July, it captured a comet hitting Jupiter, which was the first picture of two solar systems objects colliding. Later in 1995, it took the iconic picture of the pillars of creation. And in 1996, it took a picture of a tiny part of the universe with many galaxies, presumably thousands of galaxies in that single picture. And later in 1996 as well, in July, it took its 100,000th picture. And in 1997, it captured various black holes, causing astronomers to believe that there is one present in almost every galaxy. So basically, in probably 95% of all galaxies, there is a black hole in the very center, which was known thanks to the Hubble telescope. In 1998, it found evidence that the universe is accelerating because everything in the universe was moving far from itself, basically, like it was expanding. And in 1999, astronomers used the Hubble telescope observations to narrow down the age of the universe, which is presumably 13 billion years. And in 2000, it completed a whole decade in space. Also in 2000, it found missing hydrogen that was theorized to be there after the Big Bang, but disappeared. In 2001, it measured atmosphere of a planet outside the solar system. And in 2002, it helped measure the mass of a planet outside of our solar system as well. Then in 2004, astronomers used Hubble to look back in time with humanity's deepest portrait of the visible universe. So because light at a rate of 200,000 kilometers per second, if we look at objects that are very far in space, we are actually looking into the past. And astronomers were able to do that by looking at galaxies that were around 13 billion light years away. So we were basically looking 13 billion years into the past, around a few million years after the Big Bang. And in 2005, astronomers detected 2 moons on Neptune. In 2006, observations of a distant galaxy cluster showed that dark matter is truly distinct from normal matter. So because dark matter does not interact with light, it only interacts with gravity, and Hubble was able to do that and detect large amounts of it in specific parts of the universe. And in 2008, it takes a picture of an exoplanet. So an exoplanet is basically a planet that does not orbit a star. It just orbits its galaxies like stars, but it is still considered a planet because hydrogen and helium fusion does not happen in the core. So it's basically just a planet without a star. And in 2010, The Hubble Space Telescope has devised a new method for measuring dark energy, to be exact. And in 2011, it took its 1 millionth science observation. Later in 2012, it found enough information to prove that the Milky Way will clash with another galaxy, which in this case is the Andromeda galaxy. And in 2014, it finds that the Jupiter storm is getting smaller, which is expected to finally decay in around 300 or 400 years. And in 2016, it discovered a moon on a dwarf planet, which was Pluto. And in 2019, it observed an interstellar comet traveling past the sun. Its contributions to science. The Hubble Space Telescope has made 1,300,000 observations to this day. It is still in service, and it's been in service for around 30 or so years right now. Its contributions: it's helped determine the rate at which the universe is expanding. It's discovered 2 planets of Pluto, which are Greek goddesses. It has also helped pin down the age of the universe, known to be around 13.8 billion years, roughly 3 times the age of the Earth itself. It has also created a 3D map of dark matter, thanks to gravitational waves, and it has discovered that nearly every major galaxy is anchored by a black hole at the center of the galaxy itself. And in number 5, instruments, I'm just going to skip over those points to the illustration and read them off of here. So first, we have the wide field camera, number 3, which is right here at the bottom. It gives the telescope greater access to ultraviolet, visible, and infrared wavelengths of light. And right over here, we have the Cosmic Origins Spectrograph, otherwise known as the COS, right over here. There are 4 of them. They break ultraviolet radiation into parts that could be studied in detail. The COS is best at studying light, like stars or quasars, or distinct galaxies emitting tremendous amounts of light from their central regions. And right here, we have the advanced camera for surveys, also known as the ACS. It conducts surveys from the universe. It also helps map distributions of dark matter, and it detects the most distant objects in the universe, searches for massive planets, and studies of evaluation of clusters of galaxies. And then number 4, we have the Space Telescope Imaging Spectrograph right here. Basically, it combines the camera with a spectrograph, which measures a space object's temperature, chemical composition, density, and motion. So for example, if we were to study a planet in a solar system far away from Earth, this very panel right here would help detect the density of the planet, whether it's a gas planet or rocky planet, also its temperature, if it's suitable for life, and so on. Number 5, we have the near infrared camera and multi-object spectrometer. Right over here, NICMOS for short, this panel at the bottom left. Basically, it is sensitive to infrared light, which reveals details about distant galaxies, planets, and solar systems, and star formations that are not available in visible light. It observes objects hidden by interstellar dust, such as sites of stellar formation. So for example, if astronomers were to study a specific solar system, but it was blocked by space dust, this panel right here could see right through the space dust and study those objects. Number 6, we have the fine guidance sensors right over here. There are 2 of them. One is right here and the other is right here. 2 of the sensors lock into the stars and keep them pointed in correct direction. The third sensor does scientific observations, precisely measuring the distance between stars and their relative motions. So there is a third sensor, however, it's at the bottom, so we can't see it right now. And it basically just locks itself into specific stars or planets, since everything in space moves. And that's it. Now for the pictures. Right here, we have some of the most iconic pictures taken by the Hubble telescope. So first, we have the tapestry of blazing starbursts. This giant red nebula, which is basically a cloud of gas and dust in outer space, and it's which together forms part of a vast star-forming region. So right here, we could see that stars are being birthed from gas and dust. Now, of course, star formation does not happen instantly. It takes a million, if not billion years to form. But over here, we could see how it starts to form. The pillars of creation. These are multicolored gas clouds and dark cosmic dust, which is small particles of matter distributed throughout space. The dust and gas in the pillars is heated by the intense radiation from young stars and eroded by strong winds from massive nearby stars. As you could see, this alone is a few million light years long. It is huge. However, thanks to the Hubble telescope, we're able to see it all in one picture. There's a rose made of clouds. These basically what we could see flashing, and it appears to be in the shape of a rose. And here are the rings of relativity. Basically, according to Einstein's theory of relativity, light is affected by gravity. So what we could see here is it appears as if a galaxy is bending because of another behind it. But what is actually happening is the light coming from the distant galaxies is bent by a cluster of galaxies right over here. It is so massive that it even bends light, because it does not bend light, it bends space. However, the light is traveling on space itself. So the light is affected tremendously. And then right over here, we see the Bubble Nebula. Also just a cluster of gas and particles. And here is the famous Horsehead Nebula, named for its obvious shape of looking like a horse head. And this over here is a tower of cold gas and dust rising from a stellar nursery called the Eagle Nebula. Now, it is called the stellar nursery because it is a star formation area. A lot of stars are being formed right over here. And here is the cold gas and dust rising from the star formation area itself, which is at the bottom. And over here is a beautiful picture of stars making a hole in the star forming region they were made in. So here is a star forming region now. Because of some later to see. So we can access her, but however, a little space. So it kind of looks like a hole in space. And here is a dust and cloud tower, like the pillars of creation. However, this one is being destructed on the inside from stars off jets of gas. It is eaten from nearby stars. So basically, the star area is eating it. It's forming stars. However, those stars are shooting away the jets of one of the largest nebula in our galaxy. I think it's around like 20 to 30 million light years in diameter. And over here is beautiful and incarnate star forming area as well. All taken thanks to Hubble. And here is the famous Butterfly Nebula. It is tearing across space at more than 950,000 kilometers per hour. The mass of the sun is at the center. This alone is the same, has the same mass as the sun. It has ejected its envelope of gases and is now unleashing a stream of ultraviolet radiation that is making the cast-off material glow. All of this is ultraviolet radiation. And here we see the Lagoon Nebula. and over here the Crab Nebula. If you focus on the middle enough, you could actually see a white dwarf. And here, finally, but definitely not least, it is arguably the best picture of the Hubble Space Telescope has ever taken. This is a picture of numerous galaxies, not even numerous, thousands of galaxies, that alters our perception of how small we are compared to the rest of the universe. Now, this is a very, very small fraction of the universe. It can thousands, if not millions, of galaxies in this picture alone. Now, 13 billion years into the past. Now, this is actually 13 billion years ago. However, because light only travels at a rate of 200,000 kilometers per second, we can see, because it travels 200,000 kilometers per second, which seems like a really fast, a really big number, but actually, or how big the universe is. So it basically team building. Thank you for listening. If anyone has any questions, please don't be hesitant to ask. Thank you, Abdurrahman. Thank you all for attending. It was an honor teaching this lesson. And thank you very much for your compliments as well. The documents will all be provided to you guys in the chat. The presentation will also be posted on YouTube if anyone needs it for reference. There will also be a Kahoot game in a minute. I'll just have the link posted in the chat. Edaf will be here just in a minute, and she'll basically host the Kahoot games if any of you guys want to join.
Okay, hi. Can you see my screen?
Not yet enough. It'll load in just a minute.
Okay, just tell me if you
Okay, great. Yes, we can see it right now.
Okay, if you can join from your phone or from your laptop and using this PIN.
Enough. If you could also send the link, copy it and send it in the chat. So it's easier for
I think I should be the
some of
host
the
for the
attendees.
I chose this option for the game that I should be the
All
host.
right. So they could only join using the game pin.
Okay, should we start?
Okay, yes, I think we can. Just a moment. Some of them are joining and leaving. Just have them join for one last time.
Okay, I will start, and I think you can join during the game. Okay, good job, everyone. And can we know who's the smile? If you can open your mic.
It's me, Ghala.
Okay, thank you, Ghala.
Ilaf,
Yes. I know there was a
there is no
problem.
question. Yeah.
Now? Can you see the question now?
The question is on the screen. I used just my phone.
Yes, use your phone and look at the screen at the same time.
Do you need us to read the questions for you?
Okay, good job, everyone. Thank you, Sanya. And thank you for Edge. And thank you, Siva. Thank you for attending. It was nice to see you answering the questions correctly, and hope you enjoyed the lesson.
And thank you everyone for attending. It was an honor teaching this lesson. And thank you for being great listeners. And I appreciate the compliments as well. We hope to see you in the next lesson, which will hopefully be next week. Good night for now.